Thank you all for viewing my video today. This is for the technology intensive lesson plan. I chose to do mine in the area of statistics. That's kind of what I've been doing everything in this semester anyway. So I decided to stay in that realm. In particular in statistics, I'm just going to show you how to run a basic linear regression. When I originally wrote this lesson plan, I wrote it for Minitab, but since the computers in the Mac lab don't have Minitab, I switched it over to use the Inspire. So I will just show you the lesson plan that I wrote up. It's pretty simple, and show you the in-class assignment that I made, and then I'll just show you on the Inspire itself how to run the different linear regression. You can do it a couple different ways, so I'll show you the different ways, and that's about it. So this lesson plan I wrote for statistics class, Introduction to Statistics, for roughly about 30 students, which is pretty standard. The content, as you can see, is I want my students to be able to run a simple linear regression using the TI Inspire CAS CX. Some prereqs that I have listed here is that each student should have a basic knowledge of how to use a TI Inspire CAS CX. So basically how to turn it on, add pages, and save documents, and all the standard stuff that we learned. The students should know what linear regression is, and also the students should have a basic understanding of how to run a simple linear regression by hand. So basically this is a good lesson to add in conjunction with your first lesson in linear regression. And that comes usually about, I think, 3/4 of the way through the semester. So go through that basic, simple linear regression with your class, and then maybe the next class period, go ahead and run through this lesson plan using their calculators. So the instructional objective here is after this lesson, each student should be able to relate their knowledge of how to run a simple linear regression by hand to running a simple linear regression using the TI Inspire CAS CX. Let me move down here so you can see the rest. The procedure I kept pretty basic. Basically, a quick review of the definition of linear regression. Maybe just quickly run through an example just to remind them. But it should be fresh in their mind if you're doing this right after the in-class. So review the definition of linear regression. That's about 10 minutes. And for the next 20 minutes, let the students work on the in-class assignment, and that's after you go ahead and run through the example. So basically what I show you after I go through this lesson plan, take about 20 minutes to go through an example with them. You can just add some numbers like I will in a little bit, run through the example, show them all the different ways to do it, and then for the rest of the class, let the students work on an in-class assignment. I put in there, if they don't finish in class, that's fine. They can go ahead and turn it in the next day. Your materials and equipment, TI Inspire CAS CX will be used to run a simple linear regression. That's basically all you need to do. If you want to make a data set on your calculator and then give them that data set like we did in class where you send it out, that's probably a good idea too. That way they don't have to waste time adding a data set in their calculator. Assessment evaluation, each student will complete an in-class assignment. If they do not finish during class, they must turn in the assignment the following day. The in-class assignment is attached. I'll show you that in a little bit. Follow-up activities. This activity will be addressed later in the semester using a project. So after you go through the simple linear regression, maybe you move into multiple linear regression, you can do another assignment that's very similar to this. Then self-assessment. After collecting all the in-class assignments, determine if the objective was clearly accomplished. If so, a project should be assigned with confidence. If not, revisit how to use the TI Inspire CAS CX to run a simple linear regression later in the semester. So if they are not following what you're doing, if they're having a hard time with the in-class assignment, maybe before the exam or something, go ahead and run through. If you have an extra day, go ahead and just show quickly. Probably only takes about 15 minutes to review what you did there. So let me show you the in-class assignment that I made here. It says, please complete the following data for the data set contained in the file baseball.xls, which I made it from Minitab, but I can change that just to put it on the calculator. They should be completed the same way we did in class. This data set contains the amount of wins for each Major League Baseball team in 2012. The team name is in column A, the number of wins in column B, and the team salary is in column C. Please print copies of each to turn in along with an explanation. If you are not done by the end of class, please turn them in at the start of the next class. And just a simple questions that I asked them here. Create a stem and leaf plot, histogram, box plot. Are there any peculiarities in the data? If so, what are they? Create a scatter plot of the data, which I will do on the calculator here. But I'll do it for different data sets, so this really doesn't apply. Create correlation and covariance matrices. Run the linear regression. Plot the line of the data, the scatter plot. Is there a linear relationship here? If there is, what does it mean? If there's not, suggest a regression that might fit the data, i.e. Quadratic, exponential, logarithmic, etc. And then the last two problems are just predictions. So use the regression to predict the number of wins a team with a salary of $100 million would have had this year, and use a regression to predict the salary of a team that won 85 games this year. So those two, they just do the reverse. So calculate it in both ways. It'll also show you how to do that on the Inspire. So with that being said, that's just basically how I wrote my lesson plan up. So let's go ahead and do some stuff on the Inspire here. Okay, so for the first thing on the Inspire, you want to go ahead and add a new page. So if we hit Control, Doc, that brings up plus page. Just go to Lists and Spreadsheets here. We can name, these two columns aren't going to mean anything particular. I'm just making up a data set. So we'll just call those X and Y. For X, we can just do 1 through 7. And for Y, we can just make it 30, 27, 24, 21, 18, 15, 12. Okay, so there's our data set, nice and simple. Like I said, it doesn't mean anything. In the project that you can actually give this a meaning. That way you can solidify what they think the linear regression represents. Okay, so let's add another page here. And let's just add a data and statistics page. So here it is. This is the way it comes up. We can click to add our variables. So I'll click this, give it our X. Come over here and click this to give it our Y. And there we go. We see our our scatter plot of our data. It looks straight. It should be. We all know it's a negative slope of -3. So the next thing we can do here is we can come over and hit Menu. We can come down to Analyze, I believe it is, down to Regression, and click on Show Linear. MX plus B, that's the form that they would be used to. And there we go. And we can see they give the regression line there, and they show the equation for it. And if this were a data set that meant something, you could ask them, well, what do these represent? And you can ask questions like that. So this is one way that you can do a linear regression for this. Another way, if we come over and go to add another page, and let's just add a calculator page this time. So we hit Menu, come down to Statistics. We go to Stat Calculations, the first one, and Linear Regression, MX plus B, same thing as before. They ask for your X and Y variables, so once again, we'll click on those, X and Y, and it'll save the regression equation to F1, which is good. Hit OK, there we go. We see our M and our B, same as before, so that's great. We can add another page here, so Control, add a page, and we can go down to Graphs. On this page, I want to go ahead and graph my scatter plot. So to do that, we get Menu, go to Graph Entry and Edit, go down to Scatter Plot. X variable, we can hit var, and that'll give us our X. Go down to Y. Well, let me click on Y here. Hit var and Y. And we have our X and our X, Y and the Y, so we can go ahead and hit Enter there. Nothing's going to show up, but that's because the window's a little bit off, so we can go ahead and change that. So Menu, and not view, we want to go to Windows Zoom. And we can just go ahead and go down to A, Zoom Fit. That'll bring it in. We can see the same scatter plot as before. Now we want to go ahead and graph our function f1 that we found on our calculator page. So to do that, we go Menu, and we'll go to Graph Entry Edit, go back to Function. It brings up f2, but if we just hit the up arrow, that brings our f1 that we found on our calculator page. And that's the same function as before, so if we hit Enter on that, we will see our regression line. Same equation, same line, so this is just another way to do this. Now we can do the predictions. So if we go back to our calculator page, Control left, back to our calculator page, now we can do our predictions. So first, one way is plugging in an x to find our y. So if we do that, we hit F1, parenthesis, and let's just predict it for 10. Hit Enter, and our y value is 3. Good deal. Next one is to do it the other way. So this way, a little bit more difficult than this way. So if we click Menu, we go down to Algebra, hit Solve. So this brings up our solver. We can take our function f1, so f1 of x, set it equal to, I don't know, let's just set it equal to 45, for instance. And then let me set this 45 on the outside here. So equals 45, tell it our variable, which is x, and it should come up with our x value for it to solve here. And it says when x is -4, it pops out y equals 45. And those are just a couple different things that you can do with this simple linear regression. Pretty simple. Follows the lesson plan. Like I said, in your in-class assignment, like I did with baseball, you can make it a little bit more specialized. That way they can see the relationship, what actually the slope and the y-intercept and everything represents. So thank you for watching my video. Hopefully it wasn't too long. And that's it.